Hi everyone, welcome back to my channel. In this video, I will be discussing the laws of exponents. This is one of the basic concepts that you must master in order for you to simplify problems quickly and easily in mathematics, especially in algebra. So without much ado, let's discuss the first law of exponents. Well, the first law of exponent is the product of a power. So for any number x and positive integers m and n, then x raised to m times x raised to n is equal to x raised to m plus n. Well, as you can see, if the base are the same, then we can simply add the exponents. Alright, let's have examples. Let's have 2 raised to 3 times 2 raised to 5. If you notice, we have the same base here, which is 2, and the exponents are 3 and 5. Now, since they have the same base, then we can simply add 3 and 5. So that will give us 2 raised to 3 plus 5. Now, 3 plus 5 is 8, so we have 2 raised to 8. And 2 raised to 8 is simply 256. Let's have another one. Y raised to 2 times y raised to 8. So if you notice, again, we have the same base, which is y. So we simply add the exponents, which are 2 and 8, so that will give us y raised to 2 plus 8. Alright, now 2 plus 8 is simply 10. So this will give us y raised to 10. Alright, let's have another one. B raised to 2x times b raised to 2x plus 1. Well, as you can see, again, we have the same base, which is b. Alright, so we simply add the exponents, which are 2x and 2x plus 1. So that will give us b raised to 2x plus 1. Now notice that we have common terms here, okay? So that will give us 2x plus 2x is simply 4x. So that will give us b raised to 4x plus 1. The second law of exponent is the quotient of a power. So when we divide powers with the same base, exponents are subtracted, and this is for all integers m and n. Alright, so there are 3 conditions here. The first condition here is if m is greater than n and x is not equal to 0, then we simply have x raised to m minus n. Alright? But if m is less than n and x is not equal to 0, then that will give us 1 over x raised to m minus n, right? So this one, okay? Right? But if m and n are equal, alright? And x is not equal to 0, then that will give us x raised to m minus n. And since m and n are equal, then that will give us 0. And any number raised to 0, that is simply equal to 1. Alright, so let's have some examples here. Let's have 2 raised to 7 divided by 2 raised to 3. Alright, so this simply means that 2 raised to 7 is multiplied 7 times itself. Okay, so that will give us 2 times 2 times 2 times 2 times 2. And the same is true in 2 raised to 3. So that will give us 2 times 2 times 2. And since there are common factors between the numerator and the denominator, then we cancel them out. Okay, right? So we have 4 2's in the numerator and we have 1 in the denominator. So that will give us 2 raised to 4 divided by 1. Alright, and we know that 2 raised to 4 is 16, and 16 divided by 1, that is simply 16. Alright, let's have another one. But before we proceed to another example, let us first apply the quotient of a power. So if we're going to apply the quotient of a power, then that will give us simply 2 raised to 7 minus 3, and we know that 7 minus 3 is 4, so that will give us 2 raised to 4. And 2 raised to 4 is simply equal to 16. Alright, let's have another example. 2 raised to 3 divided by 2 raised to 7. This time, m is less than n. M here is equal to 3 and n is equal to 7. And since m is less than n, then before we proceed into that, let us first simplify this one. So that will give us 2 times 2 times 2. Okay, 2 is multiplied to itself 3 times. Okay, and the same in the denominator. And again, there are common factors in the numerator and the denominator, so we cancel them out, right? So what is left in the numerator is 1, while in the denominator are the 4 2's. Okay, so that will give us 1 over 2 raised to 4. And we know that 2 raised to 4 is equal to 16, so simplifying it further, that will give us 1 over 16. Now if we are going to apply the quotient of a power, right, then this will give us 1 over 2 raised to 7 minus 3. And 7 minus 3 is 4, so that will give us 1 over 2 raised to 4. And 2 raised to 4 is simply 16. So that will give us 1 over 16 as the final answer. Alright, let's have another one. This time, m and n are equal. Alright, and since m and n are equal, then this will give us, again, let's by simplifying, so this will be the output, 2 times 2 times 2. The same is true here. And if we're going to cancel the common factors, okay, so that will simply give us 1 over 1, which is equal to 1. Alright, but if we're going to apply the quotient of a power, then this will simply be 2 raised to 3 minus 3, and 3 minus 3 is 0. So that will give us 2 raised to 0. And again, any number raised to 0, that is simply equal to 1. Alright. Now, the next law of exponent is the power of a power. Now, to raise a power to another power, multiply the exponents. So in symbols, we will have x raised to m raised to n is simply equal to x raised to m times n. Alright, let's have examples. Okay, but this is for any x and any positive integers m and n. Okay, so let's have this one. 3 raised to 3 raised to 2. Okay, so this will give us 3 raised to 3 times 2, and we know that 3 times 2 is 6, so that will give us 3 raised to 6, and 3 raised to 6 is simply 729. If you have a calculator, you can double check this one. Alright, let's have another example. Let's have y raised to 4 times 5. Alright, so that will be equal to y raised to 4 times 5. So we simply multiply the exponents here, right? And the power, the exponent and the power here. So that will give us 4 times 5 is 20, so that will give us y raised to 20. Okay, let's have another law of exponent. This time, it's the power of a product. Now, in raising a product to a certain power, each factor is raised to the indicated power. And this is for any number x and y and any positive integer m. Alright, so in notation, we have here x times y quantity raised to m. That will simply be x raised to m times y raised to m. Alright, so if you notice, we simply raise the elements here in the parentheses by its exponent. Okay, so to illustrate that further, let's have the examples here. Okay, quantity x y raised to 3, that is simply x raised to 3 and y raised to 3. Alright, let's have another one. 3y squared, quantity 3y squared raised to 3. Okay, so this time we're going to raise 3 here. Okay, we're going to raise 3 here, okay, by 3, and we are going to raise y squared also by 3. So that will give us 3 raised to 3 and y squared raised to 3. Now, simplifying further, we know that 3 raised to 3 is 27. Okay, so that will give us 27, and we simply multiply the exponents here and the power here. Okay, so that will give us y raised to 2 times 3, and we know that 2 times 3 is 6. So our final answer is 27 y raised to 6. Alright, Let's have another law of exponent. This time, it's the power of a quotient. Now, for a power of a quotient, both numerator and denominator are raised to the indicated power. Okay, so we have to indicate it here. We have to write here power. Okay, such that x over y raised to m, quantity x over y raised to m, that is simply x raised to m divided by y raised to m. Alright, so we simply raise the numerator by m and we simply raise the denominator by m. Okay, but y here must not be equal to 0. Okay, so let's have examples. Let's have here quantity a over b raised to 4. So all we have to do is to raise the numerator by 4 and we're going to raise the denominator by 4. So our numerator is a, so that will give us a raised to 4, and in here we have b raised to 4. Okay, as simple as that. Now let's have here 2a, quantity 2a over 3b raised to 2. Okay, so that will give us, okay, so we simply raise 2a by 2 and we're going to raise 3b by 2. So that will give us 2 raised to 2 and a raised to 2. While in the denominator, we have 3 raised to 2 and b raised to 2. So simplifying, we know that 2 raised to 2 is 4 and 3 raised to 2 is 9. So that will give us 4a squared over 9b squared. Alright, so that's the beauty of the laws of exponent, because it makes our work a lot simpler and easier. Alright, let's have the zero exponents. Although I mentioned this while in the previous slides, but let's have more examples of it. Now for any number x where x is not equal to 0, then x raised to 0 is equal to 1. Alright, so any number raised to 0, the result is always 1. Alright, so let's have here 6 raised to 0, that is simply 1. 1000 raised to 0, that is again equal to 1. 1 million raised to 0, that is still equal to 1. Alright, and we have the last one, the rational exponents. Okay, let's have this one. 4 raised to 6 times a raised to 8. Okay, quantity raised to 1/2. Okay, this time the exponents or the power here is 1/2. Okay, so what shall we do now? Okay, this is very simple. All we have to do is to multiply the power here or the exponent here with the exponent here, and we have to multiply also the exponent here and this exponent. So that will give us 4 raised to 6 times 1/2 and a raised to 8 times 1/2. And then you simplify, right? So that will be simply 6 times 1 divided by 2, and this one is 8 times 1 divided by 2. And we know that 6 divided by 2 is 3 and 8 divided by 2 is 4. So that will give us 4 raised to 3 times a raised to 4. And we know that 4 raised to 3 is simply 64 raised to 64 times a raised to 4. Alright, so these are the laws of exponents, and you need to master all of this so that it will be easy for you to simplify problems in algebra. Okay, so thank you for watching and thank you for your time.